I've been asked by a few students about these questions I've uploaded on Edmodo, all to do with Newton's second law and involving changing mass. So I'm going to upload the solutions on Edmodo, and also what I'm going to do is I'm going to give you a video explaining them. So this one, you've got an outboard motor and a small boat, and you've got your cross-sectional area, and this is going to be your water being propelled backwards. Let me get onto a black pen here now. Way better. Yeah. And therefore, what you've got here is you've got your cross-sectional area. You're already given as 0.3 meters squared, and it's being propelled back at a speed of 8.0 meters per second. The boat, first of all, is held at rest. Therefore, again, like all these, you presume the initial speed is 0, and therefore eventually is propelled back at 8 meters per second. Calculate the rate which water is propelled backwards in kilograms per second. Well, in this one here, what you do is like the ones I showed the video before, you let time is equal to 1 second. Therefore, if you let time equal 1 second, the length of the column being ejected out of the back of this propeller is simply going to be 8.0 meters. Therefore, what you're after is I want the rate which water propelled backwards is going to be the delta M over your delta T. So this one out now, you basically go to your density equals mass divided by your volume. And what I'm trying to do is find this mass per second. And therefore your mass is then going to equal to your density multiplied by your volume. And the question it gives you here, you've already got density is going to be 1000. So then that is going to equal to 1000. And your volume is simply going to be your pi r squared multiplied by the length of your column. Therefore, that's going to be 1000 multiplied by pi. And then the radius already given to us is going to be 0.03 squared. And then you're going to multiply the length, and the length is going to be 8 meters. Apologies, that's not the radius, that is the actual, try that again, that's the actual cross-sectional area, so that is 0.03 multiplied by 8, we'll give me a radius there. Therefore, if we bung that in to your calculator, you get 240 kilograms. Then, that means then your delta M over your delta T, then that's going to equal, because it's going to be 1 second, it's going to be 240 over 1, and therefore that's going to be 240 kilograms meters per second. And then the last part of the question asks you to calculate the force exerted by the motor of the boat. Well, the force, that's going to now be equal to my change in momentum over time. Remember, the velocity is going to be constant, therefore it's going to be the velocity multiplied by the change in mass with time, which is going to be the delta M over delta T. Sometimes you bring the delta T in here, and sometimes you don't. Much difference really. Therefore, to get your final answer, you take the velocity, which is going to be 8. We multiply it by my 240, and then we get 1920 newtons. Now, technically, we should be going to 2SF, but it seems pretty daft to me to put down 1900. Technically, you should do that, but I'm going to be quite happy with 3 significant figures there. So that's the first one. The second one, we've got a water jet, and the water jet now is presumed is going to be like a cylinder. It's going like this. It's then going to hit a wall like that. And this time we have got the radius, and the radius is equal to 1.0 times 10 to the minus 2 meters squared. Now it's going with a velocity of 7.0 meters per second, and hits a vertical wall. But when it hits the vertical wall, it then runs down vertically. So if you zoom when it hits the wall, it stops moving. And that's very, very important because then the final velocity is going to be 0. Therefore, like we talked before, the wall must be exerting a force that way to stop it, because the water is exerting a force on the wall. According to Newton 3, the wall is going to exert exactly equal and opposite force. Now, to work this one out using exactly the same equation again, you're going to take your velocity is going to be your delta m over t. And it comes pretty standard with these. Therefore, your density is going to be your mass divided by your volume. Your mass is going to be your density multiplied by your volume. And therefore, we're going to take our 1000 going here. And then the volume is going to be pi r squared multiplied by L. And like what we've done before, and I'll get a different color pen, why not, is the length of this going all across here. Again, it's going to be 7 meters or 7.0 meters if you take your time, going to be 1. Therefore, getting back to my wonderful black pen, you've then got your 1000, and then it's going to be multiplied by pi. And now I have got 1.0 times 10 to the minus 2 squared, multiply the length, which is going to be 7. And you bung that on your calculator, which obviously I did beforehand. I got 2.2 kilograms. Now, to work out now the force, I'm going back to this equation here. I'm now going to take the velocity, which is 7. This now gives me my delta m over delta t, which is going to be 2.2, or we can say the mass in 1 second, which comes in here, and that gives an answer of 15.4 newtons, or we're going to 2SF. I can say that's 15 newtons. And then the very last one, I'll show you my superb artistic skills. You've now got helicopter. There you go, that's my helicopter. It's good to get for me. Then it's going to be blasting air downwards. And it's going to blast down with a velocity v. And this is where you've got the weight of the helicopter mg acting down. And as the air gets pushed down, it gives a force going up. And this force going up has to equal to the weight helicopter to make it float or balance. And what's the maximum weight helicopter if the rotor force 1000 kilograms of air downwards with a velocity of 15 meters per second? So there's my v again. And the trick in this one to realize the fact that delta, oh gosh, try that again. The delta m over your delta t, can't write anymore now, is going to be 1000 kilograms per second. And why? Because it says that each second. So work out the force. You've got your velocity multiplied by your delta m over your delta t, which is now going to equal to 15 multiplied by your 1000, which is the case that's going to be your delta m over delta t. Again, you can call the time whatever you want to, and therefore the answer pops out as 15,000 newtons. Okay, I hope that's helped you understand it. Signing out.